A city's population is 12,800. It's predicted that the population will increase by 3% each year. Write a function that can be used to find the city's population after n years. Well, we learned that in general, when we have exponential growth, it's going to take the form y equals a times 1 plus r to the power of t. So we just have to remember what all these things represent. So remember, of course, a is the initial amount. R is the rate. It has to be written as a decimal. And t is time in years. So in this particular case, if we want a function that can be used to predict the population, instead of y, I'm going to go ahead and use p to represent population. It's time for the initial amount. The initial population was 12,800. Then it's going to be 1 plus the rate. Now look, the rate is 3%. As a decimal, that is 0.03. So I've got 1 plus 0.03. Of course, that's just 1.03. And because we're writing a function, it's important to leave t in the equation. Don't leave it out. Don't plug in 15. Don't plug in anything. Of course, they did say n years, so we should probably use n to match what they said. Okay, so there you go, n years. So this would be the function that we're looking for. Now, looking at part B, if the city's population continues to grow 3% per year, what would be the approximate population in 15 years? Well, we can just use the function that we just had and do population equals 12,800 times 1.03 to the 15 power. We just put that in our calculator and see what we get. Just hit enter, and this is what we get for our answer. 19,941.98. Okay, since it's people, we will round to the nearest person. Number 2, Deb bought a new boat for $20,000. She estimates that the value of the boat will decrease. Because it's going to decrease, how will we do this differently compared to the last problem that grew? It's only one change. Yeah, instead of adding the rate like we did up here with the plus, when something decreases, we do minus the rate. The rest of it is the same. Okay, so the value of a boat. So I'm going to use V equals the initial value, 20,000, times, and it's 1 minus the rate. The rate is 12%. 12% is 0.12. So I need to do 1 minus 0.12. T years, so I will use T this time. Now, I encourage you not to leave it as 1 minus 0.12. You should go ahead and write 0.88. And this would be a good answer to put for part A. Okay, now we're supposed to graph this exponential decay function, and we could just do it something like this. Alright, this is going to be time along this axis. This is going to be value. Okay. Look, the y-intercept of this function is the 20,000. So let's see, let's call this 5, 10, 15, 20,000. So we're gonna measure this in thousands. Why does it look like there's a T on that value? Okay, so this is 5,000, 10,000, 15,000, and 20,000. Okay, so that's really good enough to start this thing off with. And so we know that the initial value is 20,000. This is exponential decay. There's nothing being added or subtracted, so the asymptote is going to be the x-axis. Here is the asymptote. So we would expect this graph to decrease and approach 0 over time. That's good enough. I didn't give you a graph or anything like that, so just a general sketch is what I wanted right there. Okay, so that's good for part B. Now, what's the domain of the function? Now, look, this is a real world problem. Time for this car had a beginning. It was brand new when she first bought it at $20,000. So we cannot go back in time. So this is going to start from 0 for this particular function and go forward. So the domain of this function is going to be 0 to infinity. If this were just a pure equation and not representing the value of a boat, then this would continue to the left and we'd have a negative infinity over here. What's the range of the function? So again, this graph really stops here at 20,000 because that's where the boat was brand new. So the range is going to go from a bottom value of 0 to a top value of 20,000. So it's going to be, the range is going to be from 0 to 20,000. What's the asymptote of the graph? The asymptote is the x-axis. That's y equals 0, because there is nothing added on to the end or subtracted. So we just put y equals 0. Now, after how many years will the boat have a value of about $4,900? To figure that out, let's put this equation in our TI-30. So you would hit your table button so you can type in your equation to get a table. So this is what it would look like in your calculator. If I hit enter right now, I'll just let it start at 0, which is fine. I'll hit enter a couple more times until I get my table. So as you can see, it's starting off here at 20,000. Now, what's that number that we're looking for? 4,900. So watch out for it to get down that low. So let's just go down. You see the value of the boat. If you keep your eyes on the y side, the value of the boat is shrinking. Okay? So right there, about at the 11-year mark, we see the $4,901. It's very close to 4,900. So we're going to say after about how many years? 11. Okay, so that was it for number 2. Now look at number 3. The function f of x has these properties. As x increases, meaning as we go to the right, f of x approaches 3. Okay, this is like an asymptote. Okay, so as we go to the right, the graph approaches 3. So let's look at the possibilities just from that alone. Let me move this down so I have some more space. Oops. Okay, so from that information alone, I know there's an asymptote at 3. So here's a graph, 1, 2, 3. So just knowing that there's an asymptote at 3, because this graph has to approach 3 as we go to the right, right away that narrows it down to which 2 choices. Which 2 of these have an asymptote at 3? Yeah, so far that narrows it down to either C or D. Those are the only ones that have an asymptote of 3. Okay, so we know it's not A and it's not B. We can get rid of that. Now, it says x decreases. As we go to the right, it approaches 3. As x decreases, f of x increases. So look, this is the x-axis. So when they talk about x increasing, they're talking about moving to the right. This would be x increasing. When they talk about x decreasing, they're talking about moving to the left. So they're saying as x moves to the left, f of x increases. Okay? F of x is like the y value here. So as we move to the left, the function increases. So as I go to the left, the graph rises. So that means I have this happening. I have this asymptote, but as we go to the left, the graph is rising. Okay, fine. That means looking at it in the normal direction, is this a growth or decay function? This should be a decay function. Okay, getting lower and lower as we go from left to right. So which one of these would represent a decay function, getting closer and closer to the asymptote from left to right? Well, that's going to be D. We know that's the decay function because the b value here is less than 1. Alright, having this one with a b value of 2, and we don't include the negative when we say this, but the b value of 2 is greater than 1, so this would not give us the decay that we need to satisfy the next one. Of course, the domain is all real numbers, and really that would be true for all of these. So that last bullet didn't really help us. But we know the answer is D. Okay, number 4. Which graph represents this function? Now, I usually start with this number on the end because that tells us what the asymptote should be. Okay, the asymptote should be a horizontal line at 3. Well, that does not help me choose between these 4 graphs since they all have an asymptote at 3. So next we look at the b value here. With this b value of 1/2, is this going to be a growth function or a decay function? This is going to be a decay function since this b value is less than 1. So, Yeah, let's call this graph A, let's call this B, let's call this C, and let's call this one D. Which of these four functions are decay functions? Yeah, just A and C. Reading from left to right, A goes downhill approaching the asymptote, and C goes downhill approaching the asymptote. B and D are both growth functions, so we can throw those out. So it's just between A and C. Now, if I were you, I would use the TI-30 to help us choose between A and C at this point. Let's go ahead and type this function into our calculator. So everyone hit the table button on your calculator, and let's type in the function. So we have 1/2 to the x plus 1 power plus 3. We just double check. 1/2 to the x plus 1 power plus 3. Okay, let's look at the table of values. Before we look at the table of values, let's identify a key point that we can pick to tell us which one is going to be the right answer. For example, let's see, graph C. Graph C has a nice clear point at 0, 4. On the other hand, graph A has a nice clear point at -1, 4. So if 0, 4 is on the graph, it'll be C. Is on the table. If -1, 4 is on the table, it'll be A. Let's see which one it is. Let's start off at 0. Okay, I see 0, 7/2. So it's looking like it's not C. So let's look back at -1 and see if that says 4. -1, 4 is on the table. So that means the correct answer is A, because it has -1, 4. That is the best way to do this problem. Use your calculator to identify some key points. Just for fun, just to make a point, look at one more obvious point on this graph. Another point where I see very clearly is the point -2, 5. Okay, the point -2, 5 is on graph A. So if I scroll back, what do you know? -2, 5 is also on the table of values. So we know for sure that it is graph A. Okay, let's take a look at number 5. A table of values for a function is shown. What is the table of values for the inverse function? Well, the table of values for the inverse function, all we do is reverse all the x's and y's. So the inverse table would be -7, -2, etc. So this would be the table of values for the inverse function. Notice I call it f inverse with a little -1. So that's the answer to part A. Now part B. Is f of x a one-to-one function? Explain your reasoning. Well, what do you think? Is this a one-to-one function? First of all, it is a function. None of the x values repeat. Do any of the y values repeat? No. All the y values are different. So we will say, is it a one-to-one function? Yes, because neither the x values nor the y values repeat. So this is what you would put for part B. Let's look at number 6. Verify that these functions are inverses. Well, let us do this properly this time. If we want to verify that two functions are inverses, we really need to do two things. We need to start with function f. So function f is 1/4 x squared. So I need to start with function f and then substitute in function g. And then on the other side I need to start with function g, which would be like this, 4x. I'll put a parenthesis where the x goes. So on this side I'll start with function g and substitute in function f. So technically we have to do it both ways. Now if these are going to be inverses, what should this come out to be? Let's see, so I'm going to put in, so I'm going to take this and put it in here, so that's radical for x. And I'm going to take this and put it in over here. So that's going to be 1/4 x squared. So you've had lots of time to think. If these are truly inverses, what should be the result of all of this? In both cases, everything should cancel out and I should be left with x. But it's important that I don't just throw an x down and cross out a bunch of stuff. I need to show it one step at a time. Following the order of operations. First, I'm going to square this. And if you square a radical, they cancel out and the radical goes away. So I'm going to still have the 4x, but the radical and the 2 will cancel each other out, so that's gone. Now I just go ahead and bring down the 1/4 part. So now I just have 1/4 of 4x. Of course, if I multiply 1/4 times 4, these are going to cancel each other out, and 1 times x is all that's left, and that is going to give me x. So far so good. Now order of operations. Am I going to do the square root and cancel out with this 2? No, we got all this other stuff in the way first. First I'm going to go ahead and do the inside part. I'm going to multiply 4 times 1/4. So in this case, these are going to cancel out first. So that's going to leave me with my square root, and it's going to leave me with my x squared in there. But of course, the radical and the exponent cancel each other out, and again I'm left with x. This proves that the two functions are in fact inverses. Okay, let's find number 7. Use this function to answer the question. Which value is not included in the domain of the inverse of the function? Now pay attention. We have to deal with the inverse of this function. Remember, for the last quiz we had, we were dealing with domain restrictions. That's what they're talking about, not included in the domain. So if we were talking about the original function, what value in this original function would not be allowed? What is x not allowed to be right now? Yeah, you probably guessed it. X is not allowed to be 0 in the original function. So if this were a question about the original function, the answer would be A. But this is not a question about the original function. It's a question about the inverse. So we need to find the inverse of this function and then ask ourselves what the domain restrictions are. So I'm going to go ahead and erase what I just did right here. Let's find the inverse. Remember, the way we find the inverse is we switch the x and the y, and then we solve for y. So please understand this f of x is basically the y. So this immediately we would write it as y equals 2 over x plus 3. Now we have to switch the x and the y and solve for y. So if we do that, switching the x and the y, we get x equals 2 over y plus 3. Now, how do I solve this for y? Well, let's go ahead and subtract 3 from both sides. That sounds good to me. That's going to give me x minus 3 equals 2 over y. Now, I'd really like to get y by itself. There's a couple strange things I could do to get this y out of the denominator, but I'm really hoping you remember the shortcut that I've been trying to teach you. What's the shortcut we can do when we want to get a variable by itself and it starts out in the denominator like this? Who remembers? I'm really hoping somebody said, yeah, we can reverse these. Okay? We can take the x minus 3 and we can take the y, and we're allowed to switch places, the denominator for this whatever's out here by itself. So this equation would become y equals 2 over x minus 3. So guess what? This is the inverse function. Okay? In fact, I could write f inverse equals 2 over x minus 3. Now it's time to state the domain restrictions. What value is x not allowed to be? What about negative 3? Is x allowed to be negative 3? Yes, it is. X is allowed to be negative 3. If x were negative 3, this would just make negative 3 minus 3, which is simply negative 6. There's nothing wrong with having negative 6 in the denominator. So, negative 3 is not a problem. If you weren't thinking negative 3, then you were probably thinking positive 3. And that is correct. X is not allowed to be positive 3. If it were, I'd have 3 minus 3, and that would make 0. And we cannot have 0 in the denominator. So, what value is not included in the domain? X equals positive 3 is not included in the domain. So, that's why the correct answer is D. Remember, I can always get this value by setting this denominator here equal to 0. If I set this equal to 0, x minus 3 equals 0, it's clear I'd have to add 3 to both sides. I should say x minus 3 cannot equal 0. That means x cannot equal 3. That's another way to look at it. Okay, let's look at problem number 8. Alright, this is problem number 8. Use these functions to answer the question. Which statement about f and g is true? Okay. Here's F, here's G. They have a little picture of G being put inside of F, and they're showing that that's going to give us X. Well, if let's just check and make sure that's true. If that's true, then they're showing that they are inverses, because if you substitute one function inside of the other and you're getting X for a result, then that's how you know that two functions are inverses of each other. So which one of these says that? Let's see. They're inverses because it's not equal to 0? No. Inverses because F at G is equal to X? Yeah, that's it. Or yeah, the other two are saying they're not inverses. Yeah, so the answer is B, based on this being true. Now let's check it and make sure it's true, but it's looking like the answer is B. They're inverse functions because if we put G inside of F, we are getting X as a result. So let's see. Start with function F, because that's first. Looking at function F, this becomes 4 parentheses minus 2. It was 4x minus 2. I write 4 parentheses minus 2. Now, inside the parentheses, I put the other function. So inside the parentheses, I put the x plus 2 over 4 function. Now, these two 4's are going to cancel each other out. So that's going to leave x plus 2 from the numerator here. Then I just have to bring down the minus 2 from right here. But of course then the plus 2 and the minus 2 will cancel each other out, and I have x. So this was true. I do get x when I plug G inside of F, and so they are inverses because of it. The answer is B. Okay, so that was number 8. And it looks like that was the end of the lesson.